Hi Seahawks, welcome to the 8.7 Solutions to Systems of Functions. Alright, so solutions are ordered pair where the two functions touch each other, so it's where they cross paths. When you're looking at a graph, it's really easy to find it, but when you're giving two functions that are algebraic, like the one below, you actually have to create a table and see where the answers all match across the entire row. So given the exponential function f of x equals 2 to the x power and the cubic function g of x equals x to the third power minus 2x, find the positive x value where f of x equals g of x by completing the table below. So we're going to substitute all of the x values they gave us, 0, 1, 2, 3, and 4, into each of the functions and see where they match. So if you plug 0 into the first function, that equals 1. If you plug 0 into the second function, you have to plug it into wherever x is. And in g of x, there's two places where x is. 0 to the third power is 0. 2 times 0 is also 0. So 0 minus 0 is 0. So it doesn't match there because you would have to have the answers match on f of x and g of x side. So for when you plug in number 1 into f of x, 2 to the first power is 2. And then for g of x, 1 to the third power is 1, and 2 times 1 is also 2, so 1 minus 2 is negative 1. And 2 and negative 1 don't match. So we keep going. When you plug in 2, it would be 2 squared, which is 4. And then when you plug in 2 on the right-hand side, 2 to the third power is 8, because 2 times 2 times 2 is 8. Minus 2 times 2, which is 4. 8 minus 4 is 4. So because both answers are the same, when x equals 2, that's your answer, is when x equals 2. All right, so for this one, they're giving you two graphs, and it says, given the graphs of an absolute value function, f of x equals 4 minus absolute value of x, and a logarithmic function, g of x equals log base 3 of x, find the coordinate where f of x equals g of x. So first thing you have to do, because we don't have any kind of table to fill out or anything, you're going to just make the points on each graph a little bit more pronounced. So if you see my orange dots on the absolute value one, and then I'm going to also do orange dots on our logarithmic function, just where they are actual points on the coordinate plane. So there's 4 on the right-hand side, and we just need to see if we can find one that matches with the absolute value on the left-hand side. So taking a look at that, I can see that there's probably one that matches, which is 3, 1, which is this one right here. And let's see if they also have a 3, 1 for the logarithmic function. And there is. It's 3, 1. So where those two, if they were graphed on the same coordinate plane, that logarithmic function would intersect the absolute value function at 3, 1. So therefore your answer is 3, 1 for the coordinate point. All right, so for this part, it says just find the solution based on the graph below. So remember, the solution is where the two lines cross each other. So this first one is a linear function and a parabola. So where those two cross each other is at the vertex of the parabola. So that would be right there in the center. And that point is positive 1, negative 2. And I wrote negative 1. It's positive 1, negative 2. And then for the second one, we've got two solutions because they cross each other at two parts on that parabola. So if you noticed, however, that the crossing of the left-hand side and right-hand side aren't exactly on the gray lines of the coordinate plane. So you need to just kind of use an estimate answer, because you don't want to say negative 2 for that, because it's not on the gray line. And then you obviously can't say that for the right-hand side. So it is close to the negative 2 line because this coordinate plane counts by 2's for every single line instead of counting by 1's. So it's approximately negative 2, but right before it. So I would say negative 1.9. And then it's also almost to the -2y line, but not quite. So I would also say -1.9 for the y. And that's for the left-hand side. That's for this point right here. And then the right-hand side is kind of right in the middle of 2 and 4 for each one. It's in the middle of 2 and 4 for the x value, and it's also between 2 and 4 for the y value. So we can use 3 for the x value and approximately 3 for the y value. And since we don't have a definitive answer, I would use the wavy equal signs to show that that's approximately those numbers. Now on the EOC, if you were given the answer of -2, -2, then obviously you would pick that with any other number, because -2, -2 is the closest answer to the left-hand side solution. And then for the last graph, remember solutions are only when the two lines cross each other. So because these two lines do not cross each other, there are no solutions or none. Go Seahawks. Woo!